This is Unit 5, Right Triangles. Preview video 5.3, SOH CAH TOA. Ready? Inhale. Deep breath, hold. Exhale. Close your eyes. Take one more deep breath. Ready? Inhale. Hold for 3. Exhale, 5. Deep breath. Let's do this. All right, it's very important that you need to have a scientific calculator handy. I'll show you how to use them. Just make sure you have one nearby. Date, time, and location. So quick recap, last class, derived from the Pythagorean theorem, we did 45, 45, 90, and 30, 60, 90 triangles. I'm going to recap the shortcut for 30, 60, 90. Short leg root 3, short leg times 2. So in this triangle here, we have a 30 degrees, which makes this our short leg. Short leg to the long leg times by root 3, which makes this simply root 3. And short leg to the hypo times by 2, which just makes that 2. I'm going to show you a decimal version of everything. So we need to get the decimal version of root 3. I'm going to show you how to do this on both calculators. Most of your calculators, you have a square root symbol in blue right here. If you have that, you're going to follow me on the right. If you can see the square root button, you're going to follow me on the left. So on the right, if your square root is hidden, turn your calculator on. Second function, that button, see that square root? 3 equals. We're going to take it to the 4th decimal place. If you can see your square root button, you simply do 3 square root, you're going to get the same thing, 1.7305. So we're going to do 3 different versions, all related to the 30 degrees. So first, we're going to take what's opposite of the 30 degrees and put it over the hypo, which is 1/2. That's going to be opposite over hypo. The next one, again, all related to 30 degrees, we're going to do what's called the adjacent side over the hypo. And the third one we're going to do is the opposite side of the 30 degrees over the adjacent. I'll explain opposite and adjacent in just a moment. Everything's related to 30 degrees. Let's get the decimal of all of these. Obviously, 1/2, the decimal is simply this. Root 3 over 2, so that's 1.7305, and we're going to divide by 2. And write that down, and that's 0.8660. And this one, we're doing 1 divided by that decimal. So I'm doing 1 divided by 1.7321 technically. And we're going to do 0.577. Okay, so these are the decimal expressions of the special right triangles. This particular lesson is going to be using decimal versions of everything. Okay, now what I'd like you to try, so I'm going to introduce you to the buttons called sine, cosine, and tangent. Before I do that, you need to make sure you're in the proper mode. Let me show you what I mean by that. Okay, look on your small screen calculators. You want to look for what's called DEG. That's called degree mode. On a small screen calculator, it should be the default mode when you turn it on. Large screen calculators. To get into degree mode, you must do this. And you must do this every single time you turn your calculator on, or you're going to get it wrong every single time. So to get in degree mode, you hit mode, down, down, over. So the word degree is flashing. Enter, clear. Do it again on this calculator. Follow mode. Use the arrows. Down, down, over. Degrees flashing. Enter, clear. Just show you a little something. These three buttons, they're called sine, cosine, and tangent. Sine, cosine, and tangent. Those are fancy names. They're just fractions. Let me prove it to you. Watch what happens. We're going to do sine of 30, cosine of 30, and tangent of 30. Let's see what happens. So I'm going to do 30 sine. Now over here on this calculator, you start with sine first and 30. Make sure you're getting the same thing I am over here. Ready? Sine of 30, enter. Make sure you're getting the same thing. The sine of 30 is, 0.5. Wonder where that came from. Let's write that down. The sine of 30 is 0.500. Exactly the same as what you just did over there. Let's see, cosine of 30. I'm going to hit clear, clear. On the left side, 30 cosine. On the right side, if you hit cosine and you see COS, follow me on the right, cosine 30, close it up, enter. Looky there, it's the same thing, 0.8660. Let's try tangent. You don't know what sine, cosine, and tangent are yet. I'm just introducing the words for you. We're going to do tangent of 30. So 30 tan on this left calculator. On the right calculator, tan 30. You should be getting the same thing, 0.5774, basically. So what do you notice? I'd like you to fill out this sentence all on your own. Fill out this sentence all on your own. What do you notice? Put it in your own words. Pause the video. Restart. Hi there. Let's continue exploring what we have learned. There's a total of 5 right triangle tools. As of this moment, you have 3. The 3 you have so far are have 2 sides, need third side, tag. That's your first one. Second one, 45, 45, 90, leg, 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 root 2. Then you have 30, 60, 90, short leg, root 3, short leg times 2. So far, all the angles we have to work with are 45, 30, 60, and 90. What happens if you have an angle, let's say that's 32 or 48? In other words, they're not an angle and a special right triangle, and you have one side, then what do you use? You're going to use what's called trigonometric ratios. Ratios just mean fractions, and those fractions are called sine fraction, cosine, and tangent. But to use the ratios, you must first be able to label a right triangle with these terms: hypotenuse, opposite, and adjacent. We're going to use this symbol theta to represent an unknown angle, just like you use X to represent an unknown number. In geometry and trigonometry, theta we use for angles. Let me show you what I mean here. So if we are working, I'd like you to physically sweep this angle theta. Now the hypotenuse doesn't change. The hypo is always across the right angle. So this squiggle would be the hypotenuse. Adjacent and opposite can change depending on the location of the angle. So in this case, if my theta is here, my opposite is across from it, but not the hypo. And then my adjacent is touching the theta again, but not the hypo. So that would be the opposite and adjacent. On the right-hand side, our theta has moved. Find your hypo right off the bat. That's across the right angle. So this would be the hypo. You go across from the theta. That is your opposite. Next to your theta, but not the hypo, is your adjacent. That's how you label opposite, adjacent, and hypo. You do these two. Your theta is given here and here. Label the hypotenuse, the opposite, and adjacent. Should take you 20 seconds. Pause. Welcome back. You should be correcting in red pen, friends. Hopefully you did this yourself. In this case, your hypos are both across from the right angle. So your hypos are here, 24, and here. You're not solving for anything yet. You're just labeling. Your opposite of the 54 is here. Your opposite of the 21 is here. Your adjacent side of the 54 is here. Your adjacent side of the 21 is there. Now that you can label opposite, adjacent, and hypo, now we're going to focus on our fractions. The ratio of two sides of a right triangle, just remember it's a fraction, in reference to a certain angle, these ratios have names. So we are going to make everything in reference to angle A. So sweep A, and let's label hypo. This would be our opposite. This would be our adjacent. Now we're going to make fractions and turn them into decimals. So in this case, our opposite is going to be the number 3 over our hypo, which is 5. 1/5 of a dollar is 20, so 3/5 is 60. So our opposite over hypo ratio in this triangle, in reference to angle A, is 0.6. Let's keep going here. Our adjacent, in this case, is 4 over our hypo, which is 5. So 1/5 is 20. So 4/5 is going to be 80. Opposite over adjacent, that ratio is going to be obviously 3 over 4. 3/4 of a dollar is 75 cents. Now, all three of these ratios have names, very particular names. And this first ratio is called the sine ratio. Second one's called the cosine ratio. Third one's called the tangent ratio. I'd like you to circle the first letter of each word. Sine, opposite over hypo. So cosine, adjacent over hypo, CAH. Tangent, opposite over adjacent, TOA. That's where this acronym comes from. It is a reference to the order of the fractions. I'm going to act this out. You're going to do this at home too. Ready? And so, like you're proving a point, you're making a statement. So, you're going to sound like a crow. Put your arms under your armpits. Ready? And the last one, pretend someone stomps on your foot. Ow, you're in pain. And you're putting your fingers on your toe and you're saying, TOA, ow, TOA. So, TOA. Remember that acronym. Let's get the SOH CAH TOA ratios. In this case, ready? We're going to use the reference angle Z and label our opposite, adjacent, and hypo here. There's your right angle. So that is your hypo. Across is your opposite. Next to is your adjacent. So in this case, our cosine of angle Z, our cosine ratio is going to be adjacent over hypo. So our adjacent here is 20. Our hypo is 29. So if I want the cosine ratio in decimal form, I come over here, simply do 20 divided by 29. We're going to take everything out to the fourth decimal. There's a reason why. 0.6897. So that decimal is considered the cosine ratio of angle Z. I'd like you to try this one on your own. Pause the video. Get out your red pen. Welcome back. So tangent is, we're going to start by working angle A. So in this case, 17 is the hypo. 8 is across from, so that's our opposite. And this would be our adjacent. So the tangent ratio is going to be TOA, so it's opposite over adjacent. My opposite here is 8, and my adjacent is 15. Let's get the decimal version. 0.5 repeating. So you can see what's going on here is in your calculator are stored hundreds and hundreds and hundreds of these ratio fractions. And they have been calculated to be corresponding to certain degrees of angles. And if you're curious what that looks like, so here's your cardstock page right in the middle here. What's right before is what's called a trig table. So all of these decimals are stored in your calculators. So that's where these decimals are coming from. They are ratios of sides in reference to certain angles. So for example, the sine ratio of 30 degrees is 0.5. So if you look here, you go down the sine column and you find 0.5, you can see the sine ratio, you work backwards, is of 0.5 is 30 degrees. Same thing here, cosine of 30 degrees, 0.866. backtrack it. And the tangent ratio, same thing, all 30 degrees. So you can see how the ratios correspond to the decimals, and these decimals have all been stored in your calculator. So you don't have to use this giant chart, although in class I'll show you how to use it if you'd like to. Now I'm going to show you how to use these amazing ratios to find side lengths not involving 30, 60, 90 or 45, 45, 90. Ready? We'll do it together. Don't be intimidated. It's quite easy. First, you start by finding your reference angle. In this case, it's 24. Why am I using that? It's the only one that's given. Identify your hypo. Identify your opposite. Identify your adjacent. You want to have your reference booklet flipped to the sine, cosine, tangent page. Let me show you what that looks like. You want that handy. So this was the page we were working on, Pythagorean theorem, 45, 45, 90, 30, 60, 90. Flip it over. And we are on the side that says SOH CAH TOA, how to find sides. Make sure you're only looking here. Keep this right underneath your nose right now. Right here. Keep it close. This is the side you're using. Keep it very close. Have, need, do. In this scenario, we have a number for the hypo, which is 16. We need or want the opposite. That's going to be our x. So what do? Which ratio do we use? We have an OH combo. Technically, it's HO, but that order doesn't matter. This order does matter. We know with OH is so. It's very important you follow my instructions right now. Don't try to take shortcuts. Copy exactly the sign ratio. Why are we using sign? Because we have an OH combo. O, so. Copy exactly that down right here. Looks like this. Sine of the angle theta over 1 equals opposite over hypo. Step number 1, always write your equation. Actually, step number 1 was label, excuse me. Step number 1 was label. Step number 2 is your equation. Step number 3, circle, plug, chug. Let me show you what I mean there. Sine of theta, we circle theta. Come over here, your theta, your angle is 24. You write it like this. Sine 24 degrees, put parentheses around that whole thing, over 1 equals. Circle the word opposite. Come over here. Opposite x over, circle the word hypo, hypo 16. We're going to solve for x here. Super duper important. Do not touch your calculator until x is by itself. You have to isolate it. Please do not touch your calculator until x is by itself. Let me show you what I mean. Ready? I'm going to cross multiply. So we have 1 times x equals 16 times sine 24. Okay, in this case, x is right now by itself because there's a 1 there. We are going to put this 16 times sine of 24 in our calculators. There's 2 ways to do it. Taking a look here. I'm going to start with sine of 24. So on this calculator, you hit 24 sine. This calculator, sine of 24, enter. Notice I hit enter both times, so you get the same thing. See that? Then we are timesing by 16. Times 16, enter, times 16, enter. Take it to the second decimal, which is going to be 6.51. 6.51. Congratulations, you just found a side length of something that's not a special right triangle. 6.51. Let's check for units. No units, so we're just going to say units generic. Now, what's nice is you can kind of just check this logically. Let's just take a look here. All right. So my opposite here is going to be 6.51 units. Okay. Just kind of check it logically. My longest side, which is the hypo, should be 16. So if I get something bigger than 16, it's like, oh, probably wrong. Got it? And it's also a smaller angle. It's not a large angle, so we know this is going to be significantly smaller than 16. So just take a moment and do a logic check here. So this showed you how to do that on the calculator on the right. We're going to do a couple more here. You'll get the hang of this. It's not hard. Step one, we label. Right here, there's our hypo. If we're using this angle, that would make this side the opposite. So in this case, we have the hypo, which is 11. And this time we want the adjacent, ADJ. So we look here, we have a AH combo. And you ask yourself, looking on this chart, what goes with AH? And the answer is like a crow. So copy exactly this down, exactly as you see it. Oops, let me keep my color straight here. My adjacent is green. And my hypo is here. Now, we circle plug chug. We cross multiply. And plug stuff in. So our cosine here is of 58 over 1. Our adjacent circle is x. Our hypo circle 11. Please always circle. Put parentheses around cosine 58. This is not reading the number 58. It's the cosine ratio of 58. So this is a single entity. Keep that in mind when you cross multiply. This is going to be x equals cosine 58 times 11. Cosine 58 times 11. Now x is by itself. We're going to grab our calculators. Make sure you follow and do the same thing. Get clear and clear. So we're going to do cosine 58. On the right calculator, it looks like this. Watch. Cosine 58, enter. Should get that decimal. On this side, it's 58 cosine. Same decimal. We are timesing by 11. You're going to take it to the second decimal, 5.83. 5.83. Come over here, x equals 5.83. Check for units, no units. So we go like this, units. Now just do your logic check. If our hypo is 11, then our side length has to be less than 11. And we have here 5.83. And if this is 58, over here, that's going to be 32. So here's how you do your check. Smaller angle, smaller side, larger angle, larger side. Ta-da! Logically, it fits. Let's do another one. Have, need, do. Start by labeling. Hypo. That's your angle. That would make this your opposite and this your adjacent. Have, you have the opposite and you want the adjacent. So we have an OA combo. What goes with OA? OA. That's going to be tangent. So copy exactly this down as you see it. Tangent of theta over 1 equals opposite. Please don't take shortcuts and put your numbers in here right off the bat. Always write down your original equation. Now, circle plug chug. With theta is 47. Put parentheses around that whole entity. Circle opposite, 20. Your adjacent is x. Remember, never touch this calculator until your variable is by itself. That's super important. Because in this case, your variable's not yet by itself. So it's going to be tan 57 times x equals 20. You must get rid of that tan 57, cancel it out. Opposite of timesing is dividing. Excuse me, 47. I kept saying 57. 47. Got it. So in the margin, x is going to equal 20 divided by tan 47. Now, x is by itself. Now you may use your calculators. So now you have x by itself. X equals 20 over tan 47. This is what it looks like on the right-hand side. So it's going to be 20 divided by tan 47. Follow along. You hit 20 first, divided by tan 47. See that? Enter. On the right-hand side, it's 2 steps. You do 20 first, divided by 47 tan equals. You should be getting the same thing. Make sure you get the same thing as me, 18.65. So x equals 18.65. Check for units. And so right here we have 18.65. And you can check your math here. This is going to be 43. And smaller angle, smaller side, larger angle, larger side. You know you're correct. All right, take 1 minute and summarize what you learned in today's lesson.